Good morning, students. Today we will see the modulus and amplitude of complex numbers. In the previous lecture, we have seen what is complex number, what is I, power of i's. Now we are studying what is modulus and amplitude of complex number. Let us see the complex number z is equal to x plus iy. It is imaginary axis, it is real axis, and let us suppose this complex number be here px comma y represented by point p. If we join this p to origin say o, this is modulus r, and the angle made by modulus with positive real axis say theta is amplitude. Now what is r? R is modulus and theta is amplitude. Now drawing the perpendicular from this point P on real axis, we get right angle triangle POM. In this triangle POM, we can find the value of r with the help of Pythagoras theorem. It is x and it is y. By Pythagoras theorem, we get x square plus y square equal to r square. Therefore, r is equal to square root of x square plus y square. This is formula to find out the modulus of complex number denoted by mod z. It can be written as mod z also, modulus of z of the complex number. And now, to find amplitude, it depends on the position of complex number. Complex number may be lying in first quadrant, it may lie in second quadrant, it may lie in third quadrant, it may lie in fourth quadrant, or positive x-axis, positive y-axis, negative x-axis, negative y-axis, and this x-axis and y-axis are known as real and imaginary axis for the complex plane known as Argand plane. The first case, number first, when the complex number lies in first quadrant, at the time we can use the formula theta is equal to tan inverse y by x only. Why? Because if we obtain a tan theta from this figure, tan theta is equal to tan theta equal to opposite side upon adjacent side or perpendicular upon base y by x. Theta equal to tan inverse y by x by the definition, considering the inverse is possible here, theta equal to tan inverse y by x. If the complex number lies in second quadrant, at the time this will be pi minus tan inverse y by x. Why it is, we have studied in trigonometry. Then number third, that is when it lies in third quadrant, then theta will be equal to tan inverse y by x minus pi or pi plus tan inverse y by x. This will not be in your principal value. This is principal value and this is another value of the modulus. But here one thing, note that it is always modulus, here also modulus, mod. Number 4, if the complex number lies in fourth quadrant, at the time theta is equal to minus tan inverse of modulus of y by x, like this modulus. And don't confusing between this modulus and this modulus. This is modulus of complex number and this is mod only for getting only positive values, absolute values of number, minus tan inverse mod of y by x. When the next case, when the complex number lies on positive real axis, it means that this complex number lies at any position on the positive real axis and the coordinates on that part of the axis are like a comma 0 means a is the real part and imaginary part are 0, means this complex number is only the real complex number. At that time, no need to use any formula. You can directly say that there is no amplitude. This the value of amplitude is 0. We can directly say theta is equal to 0 here when the complex number lies on positive real axis. Next case, when the complex number lies on negative real axis, at that time you can note that it lies on this part of the figure, here, anywhere this point lies, this position of complex number will be here. And if you take the angle with the positive real axis, this angle will be 180 degree, means pi radian. At that time also, no need to use any formula, we can easily find it. Theta is equal to pi radian. Note if that if the coordinates of point means the complex number z is equal to like minus 3 plus I, it is, and this coefficient of I is 0, 0 I, at that time the amplitude of the complex number is pi. Next case, when the complex number lies on positive imaginary axis, it means that, see in the figure, that this complex number will be here, anywhere above above this real axis, and any complex number lies on this having coordinates 0, something say b, and if complex number like this, at a time you can check here by drawing it directly the angle. This angle is no doubt pi by 2. At that time, no need to use any formula to get this. You can write theta is equal to pi by 2 radian only. And now in the next case, when the complex number lies on the negative imaginary axis, at that time the position, let us see in the figure, at that time the position of the complex number will be here at that time. And if we take it in this direction, negative direction, it will be minus pi by 2. Again, no doubt it is correct. No need to use any formula to get it. When the complex number lies on positive real axis, negative real axis, positive imaginary axis, negative imaginary axis, you know directly the amplitude 0, pi by 2, minus pi by 2. And if the complex number lies in quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant, you must have to learn these formulas. And after getting this theta and r, we can change the form of complex number, and we know that x plus iy is Cartesian form of complex number. From this figure we get x is equal to r cos theta and y is equal to r sin theta. It will be like this. And if you take r outside, cos theta plus I sin theta, this is one form of complex number, and this form is known as polar form of complex number. It's okay? Understand everything? We'll see the remaining part in the next lecture. Thank you very much.